Hello and welcome to my showcase project for my mobile application Insta-Translate. The aim of Insta-Translate is to refine and expand upon existing translation apps. I've done this by adding functionality to find any grammar or context issues after a translation, including a history to go back to frequently used translations, and improving overall usability and accessibility. The target users of the app would be anyone visiting a foreign country they do not speak the native language of, either for a holiday, for work, or even to study. The app is designed to be used in real-life situations where a user needs immediate assistance with translation while interacting in a foreign language, such as transportation, ordering food, or communicating with locals. Here is how it works. First we hit the speaker button and say we want to translate. Can you give me directions to the nearest train station? It's now showing what we said as text on the screen, and we have the option to change the language. I'm just going to leave it on French and hit the translate button. It now shows the translation as text, and if we hit the speaker button here, other new features include the settings page, which allows you to change the language the microphone expects, and also the history page, which shows all of our previous translations. We can then swipe right on these to remove them, like this one about eels. And then we can also go back to our previous translation here, press it, and then listen to it again on the speaker screen. When designing the navigation, I focused on user flow, which is emphasized in the book Refactoring UI as a critical aspect of design. The user flow ensures that users can efficiently complete each task, like recording their voice or listening back to the translation, by guiding them smoothly from one screen to another, minimizing cognitive load, reducing friction, and creating a predictable and consistent experience. This approach helps users stay engaged, enhances their confidence, and ultimately leads to a more satisfying and intuitive interface. This was all implemented using React Native Stack Navigator library, which was used as it organizes screens into a stack, mimicking the way users would naturally think about the tasks in a sequential manner, as well as having options for history, backtracking, and parameter parsing. Each button displays icons that appear in real life or frequently used in other applications, has a consistent shape and color, is in a convenient size and position for the thumb, and has some kind of feedback when pressed. All these design decisions work together to make it obvious for a user to understand not only that they are a button, but also what they will do if pressed, and that they have been pressed. This was achieved by creating a unified and contrast-friendly color scheme, which keeps the buttons consistent and visible, using the touchable opacity component as opposed to the standard button or pressable, as it provides an automatic opacity decrease when pressed, providing feedback. And finally, the Material Community Icons component provides a large library of icons to use and customize. To make the application as accessible as possible, each button also had the accessibility attributes of label, role, and hint added so they can be utilized by the device's accessibility applications, for example, the screen reader. When the microphone button is pressed and recording begins, the icon on the button changes to a stop button and an animation plays. These together let the user know that it is now recording and the purpose of the button has now changed. The recording implementation uses the Expo AV library. There are other options for speech-to-text, for example Expo Audio or Expo Speech Recognition. I settled on Expo AV as the others had compatibility issues, so I would have had to make the app specifically for Android or iOS, which I didn't want, as an aim for the app was to make it as accessible as possible. The animation uses the React Native Animated API, as the animation itself is simple and didn't require anything more complex to be effective as a form of user feedback. The translation screen first shows the transcription from the recording as text. This is so that the user can see if any mistake has been made and rectify it. A drop-down menu is used to select the language to translate to. This is useful as it conserves screen space, keeps the interface clean and uncluttered. The transcription is created by sending the recorded audio file to the Google Speech-to-Text API. This method was chosen again due to compatibility issues with other libraries and APIs. That's not to say I didn't run into compatibility issues with Google, but was able to make it work with any device by specifying recording options like file type, encoding, and sample rate, then sending these details to the API. The drop-down menu is implemented using the Expo Picker library. Picker creates a style of drop-down menu based on the platform it's on, which means its functionality should be recognizable to the user. When the translation button is pressed, the transcription and selected language is sent to the Google Translate API, which as of 2023 is still rated one of the top translation APIs available. The speaker screen first shows the translated transcription in the language that was chosen, but that's not all. It also has been checked for any potential grammatical or context errors. The text can just be shown on screen to whom the user is communicating, or the speaker button can be pressed, which plays the text from the device's speakers as speech. This gives the user and who they are communicating with optionality and accessibility. The translation refinement is completed by OpenAI's GPT AI language model API, specifically version 3.5. Currently, this is the most advanced free version of GPT available, which is why it was chosen, but this could be updated in the future, for example with premium paid-for versions of the app. The text-to-speech uses the Expo speech library, which again was utilised due to the out-of-the-box compatibility with multiple devices. Each saved translation on the history page is displayed as a separate card in a list. Each card can be pressed to return to the speaker screen, or swipe left, revealing the button to delete the translation, mimicking the behaviour of how cards work in other mobile apps. Both the settings and history are implemented by using the SQLite database library, as each section needs its own table with its own data, and the history table potentially having multiple records. Having an on-device database was required, even though it doesn't currently utilise any relational aspects. The history cards require both the Expo gesture handler library for the swipe left function and the reanimated library. The reanimated library is required due to the card background colour being consistently transparent. It meant that the delete button appeared behind the card without swiping. The animation changes the opacity of the delete button so it only appears when the card is swiped.